Hello, this is my lab report for Lab 2, Motion of a Falling Object. The purpose of this lab was to determine the effect of gravity and drag on the motion of an object, which in my case is a paper ball. I made two models, one for gravity as the only force, and one as gravity and a drag force as the forces acting on the paper ball. They were made using Python. The fundamental physical principles evident in this lab are Newton's second law, the momentum principle, and drag force. The main result is that the model that included both gravity and the drag force most closely followed the observed motion of the paper ball. Newton's second law says that the force on an object is the mass of the object by the acceleration of the object. The momentum principle is essentially an altered version of this principle. It states that the change in momentum in a system is equal to the net force applied multiplied by the time. In the gravity-only model, we assume that the only force acting on the object is gravity. Because there is a net force acting on the object, according to both principles, the paper ball will experience a change in velocity. The drag force states that there is a force opposite to the direction of motion. This force has the magnitude of a proportionality constant b times the square of the speed. In our model, this drag force will cause the net force to have a lower magnitude than expected due to it being in the opposite direction of gravity. In our gravity-only model, the initial position of the paper ball was negative 0.0003 meters in the y direction, which is negligible. The paper ball was initially at rest, and b was 0. The only net force in this model was gravity. To update the paper ball's velocity and position, I used the momentum principle, seen in lines 75 and 77. In the gravity and drag model, we had the same initial conditions, but b was 0.0069404. B was calculated using a guess and check method until the model gave us the observed final position. The forces acting on the paper ball is the force of gravity pointing down and the drag force pointing in the opposite direction, or up. Again, we use the momentum principle to update the velocity and position. In our experiment, the system was the paper ball, and the surroundings was the Earth, the air particles, and the rest of the universe. I dropped the paper ball from a certain height and used Tracker to track the motion of the object to get the change in y position over time. I then compared the observed motion to both models. It was found that the gravity model overestimated the position of the object due to not accounting for the drag force acting in the opposite direction. The gravity and drag force model most closely aligns to observed motion, especially at the beginning and end, but still overestimates position most of the time. However, it most closely accounts for the true net force acting on the system. The discrepancy in the observed motion in the gravity and drag force model can be attributed to the distortion of background due to the tilt of the camera. This could cause calibration issues, so the observed y position could be wrong. Also, the irregular shape of the ball could have caused a non-constant b, so the observed net force is different than in the model. If the models were allowed to run for 1 second, it is apparent that the gravity and drag model graph has an asymptotic nature, which implies that the velocity will not exceed that point. This is a predicted terminal velocity, which according to the model is about negative 2.18 meters per second in the y direction. At this point, the drag force and gravity are equal and opposite to each other, so there is 0 net force, and therefore a constant velocity. The gravity-only model does not exhibit this. Additionally, if the object was thrown down, the terminal velocity would still be the same. The force of gravity is constant, and the drag force is catching up to it, so the net force will inevitably be 0. As seen in the graph, the initial velocity is now negative 3 meters per second in the y direction. The terminal velocity is still the same. Thank you for watching my video and have a great day.